So we'll start meteorology. In meteorology, the chapter number one, as you all know, what is given is atmosphere. But meteorology also, I mean, I was not doing as per the chapters, the ascending order what they had given in this IC Joshi basically. I usually divide meteorology into two parts. One is your basics, another one is your advanced. So advanced is basically if you don't know basic things, then you can't visualize this advanced. There is nothing to visualize. Everything is conceptual. Like advanced in a sense, your pressure, temperature, density, humidity. These all are basically advanced. I mean, basic concepts, and mainly your winds. Without winds, there is nothing. And when we talk about the advanced, by using this concepts of pressure, temperature, density, and all, we are talking about clouds, we are talking about jet stream, which is very much important, cyclone, thunderstorm, shortcut is TS, and your tropical system and your climatology. These are all the advanced topics basically. We will spend a good amount of time in the basic concepts because once the basics are done, then advanced you can easily aram go with. And out of box, after this two, basically, the crux what you are going to see is your meta reports. Meta, TAF, trend, these all are basically your meteorological codes. Basically, we will discuss this at the end. Basically, there is one chapter in your IC Joshi, that is station model is also there. Station model we will discuss, but this is mainly with respect to vessels, basically the sea crafts which are there. They will be using this station model, but we will discuss station model as per the exam basically. But one chapter which I always I feel very much boring with is basically this chapter 12, sorry, correction, chapter 22, that is your radar CR. I mean, it is very factual basically, like how many meteorological watch office is there, how many aeronautical watch office is there. These are all like numbers, 54, 8. These are all numbers basically, which I don't feel very much good. But except that chapter, all the other chapters which is there in IC Joshi, it is brilliant. I mean, even for the exam also, again, for metrology, I will give my own note itself. You can go with that also. But if you want, you can go with the IC Joshi also. IC Joshi, for the exam purpose, honestly, I would say it is a god. You agree or disagree with me? Back questions of IC Joshi will be there in the exam. At least 10 to 15 will pakka you will get basically. Some attempts you will get 25 also, 25, 30 also basically. Straight away question, not even a single word is going to be changed in the option also. So back questions are mandatory. Without back questions, if you are going, you are doing a sin. Oxford, if you have a time, you can prepare for back questions. But reading Oxford is not recommended right now. I personally took 3 months to read the Oxford of Met basically. So 3 4 months you have to invest like daily 5 6 hours or 7 hours. Or else it is quite difficult to. You can do it, but now it is not required. When you go for flying after you clear your papers, there you can study if you want. So first we'll go with the basics of metrology.
So, like you will be providing question banks also format because this time also from IC just 12 or 13 questions came in
No, no,
rest.
no. This time also I know, like I see Josh, I always see the questions of of that particular attempt
Mhm.
basically. There is one, I don't know, this time it's regular basically. Like there is one very favorite topic of DGCA, that is fog basically,
Fog,
radiation
yeah.
fog, advection fog and all these things. There are a lot of questions which they will ask from this fog. And with respect to winds also. And with respect to your climatology, they are going to ask a lot of questions. Climatology is combination of all your chapters, whatever you had done earlier. So again, for that, I would guarantee you the concepts which we are going to discuss over here, that is more than enough. No question bank. Whatever the question bank it is, you are going to do it. But for the exam reference, because IC Joshi back questions will come, please do it. It is mandatory. That is, without that, you can't give it. Okay. Now, before, shall we start the classes? If anything else is there, you can ask, or else we'll start. Okay. Before we move into first chapter, today and tomorrow probably I will not be still ending, I mean, going with this chapter. First, I need to discuss some basic things with you guys. After that, only we are jumping into the class. And these basic things are fundamental. If you are not going to understand this, it is very difficult for you to go with the Met. Meteorology is a very interesting concept, at least for me, and it is very easy concept. क्योंकि इसमें रटना कुछ नहीं है. Everything is conceptual. Met, nav, and tech. nothing to by heart basically. Everything is logical and conceptual. But problem ये है कि मेट्रोलॉजी में एक क्लास मिस हुआ, अगर वो concept नहीं पता है तो आपको it is going to create a lack. So at least for meteorology, please do not take a leave basically until and unless it is not very much emergency. There is a chapter called as stability and instability. People will by heart this stability and instability. Those who have cleared, even they do not know what is a full form of, I mean, what is a correct way of studying stability. This chapter, if you got absent, you are not understanding how clouds will form. If clouds did not understand, thunderstorm you will not understand. Your cyclones you will not understand. Your climatology you will not understand. So everything will be messed up. So that's why request for meteorology, please do not take a leave. Okay, we'll start. Yeah, see, for me, when we talk about meteorology, I feel there are four things which are very fundamental, without which there is no weather, there is no atmosphere in our world, basically. We are not studying meteorology if it is not there. Number one is your temperature. Number two is your pressure. Number three is your water vapor. Water vapor, although it is only 4% in the atmosphere, without water vapor, it's going to be complete desert. Number four, uh, quite conventional, I would say, mountains for me. Mountains play a major role when it comes to India. You are, having a chilling and warm atmosphere thanks to Himalaya because it is the cold currents which are coming, the cold air coming from China and all, it is preserving. And the rainy season also, rain and all, we will discuss how the mountains are influencing. And last one part, I feel dust. I mean, it is obviously it is negative. It is creating the pollution in the world basically, but some sort of dust particles are required, and this also you will get to know why. I mean, it is they used to say basically everything which is in world is not waste. So dust you may feel it is waste, but it is called as nuclei. It is something like there is a dust particle. Over that dust particle, the water droplets are going to form. If there is no dust particle, if there is no nuclei, we call it as hygroscopic nuclei. Hygroscopic. If there is no hygroscopic nuclei or dust particle in simple way, your water molecules are not combining and becoming bigger in size. If water molecules are not becoming bigger in size, cloud formation is not happening. So that's why you may probably see sometimes IIT Delhi or this IIT Madras, these guys are going for the air by the aircraft and they are pouring some sort of chemicals and we name it as cloud seeding. Cloud seeding is nothing but we are forcefully creating the clouds. I mean, we are making it saturated and making the clouds to form the rain. We'll discuss in detail about this also. But in cloud seeding, you are pouring some chemicals. For example, for your easy understanding, you take salt. Salt is one of the best example of your hygroscopic nuclei, same like dust. In salt, if you keep the water, salt will absorb the water in a very good way, basically. So, like that only in the cloud seeding, also some chemicals are there which we will discuss later. Those chemicals will be poured into the atmosphere. When they are poured into atmosphere, water vapor which are surrounding in the atmosphere, they will come and sit into this chemical and they will form the water droplets and thus becoming bigger in size, they will become as a clouds and they will saturate and they will give a rainfall. So, what is this saturation? What is this unsaturation? These all things we will see. But this five are very important in an area or in a region if the atmosphere has to form. Now you take polar region. In polar region, temperature is low. If temperature is low, there is no enough pressure required for cloud. Water vapor, clouds are nothing but the water vapors. Clouds are made up of water vapor. When the temperature is very low, the air molecules are not moving up. It means the water molecules are not moving up basically. Next, there is no mountains I'll make you to relate later. But in polar, there is no dust particles also. So even somehow if the water goes into the top side, there is nothing over which this water molecule can sit. So again, the clouds are not going to form. So that's why I would say these are the five elements for me. I mean, this is not given in Oxford or IC Joshi. Don't take this into the exam basically. I'm not a meteorologist in a proper way. But आईसी जोशी और ऑक्सफोर्ड समझ पढ़ के जितना समझ आता है उसमें दिस फाइव आर द टॉप थिंग्स बेसिकली. First, I will talk about the temperature. आई मीन यहाँ पे सब बेसिक चलेगा, इसके बाद व्हेन वी स्टार्ट द प्रेशर, टेम्परेचर, ह्यूमिडिटी, ऑल सेपरेट चैप्टर्स, देयर वी विल डिस्कस इन डिटेल. But for me, today I mainly need to go with this general circulation. To connect for general circulation, I need all these things basically. So I hope you all remember. Yesterday also I mentioned I will first do the general circulation in IC Joshi. After that only I'll move into other chapters. Now, can anyone say between tropics? Yeah, tropics. I hope you all know basically. 1 minute. Hmm. Okay. If this is a equator, till 30 degree, till 23 and a half or 30, you will consider this as a tropics. Very basic thing, geography. 30 to 60 degree, you will consider it as a temperate region. 60 to 90 degree, you will consider as a pole. Now, of course, where temperature is more, on tropics or on pole? Uh,
Tropics, sir.
Tropics. So temperature on the tropics is more. Now let's imagine an area, in a same area, in a same region, let's say, in one side, temperature is less. In another one side, temperature is higher. Now let's consider air molecules over here. Same quantity of air molecules are there. Imagine this is the same quantity. Now air, to move upside, if it is going against to gravity, someone has to push it from downside. Now who is pushing that basically? Temperature is pushing. So when the temperature increases, let's say this is your air molecule, this is in the cold region. But when the temperature increases, air molecule expand. So when they expand, this area, which was earlier only covering this much, some air molecule will go out of this area also. So basically, the air molecules are expanding in the higher temperature. That's what I'm trying to say right now, currently right here. Any doubts till now? Okay. Now, let's come to this. In this region, the temperature is lower. In this region, the temperature is higher. This is your equator. Imagine this is your pole or any of the region. On one region temperature is higher, another one region temperature is lower. In this region, because the temperature is higher, it means someone is pushing from downside for the air molecules to move into higher region basically. So what happens when you increase the temperature, because the force is, I mean, kinetic energy is generating upward. See, wind, there are two types of wind in broad way. If the winds from ground, they are moving upside, it is called as convection. Convection is nothing but wind movement vertically. This is called as convection, and this is also called as updraft. And the wind which is coming down, this is called as downdraft. Now, this word is important. On the ground, if the wind is moving from one place to another place horizontally, this horizontal wind movement is called as advection. For example, vertically movement is convection, horizontal movement is called as advection. Now, why air will move vertically, why air will move horizontally, that we will see in this. That's the reason why I'm taking this. Shall we move on? Now, in the equator region, you have higher temperature. Higher temperature means air molecules are expanding. Earlier, the air molecules was only right till here, but now they are expanding and they are going into higher region. Is it okay? Everyone agree with this? Now, what do you mean by pressure? In simple way, before we get into the language of the pressure, basically, language is basically your force by area. But what do you understand by this force by area? Pressure means what basically? Anyone has seen this movie Ghazi Attack? There is a Hindi movie, Ghazi Attack. I mean, now I'm not recommending to watch the movie just to understand the pressure basically. But if you had seen in that one scene is there, which is with respect to X basically. Now see, what do you think? Your body is feeling the pressure. This part we are mainly going to study in tech gen. In the technical general, when you do the basics basically, there you will study this. But what do you think so? Your body is experiencing pressure in the atmosphere. Now, or else before we get into this, in your hand, let's say you have two bricks on one hand. In another one hand, let's say you have four bricks. Which one is going to get more pressure? Which one is
Oh,
going to get more pressure? Number two, basically, in this, pressure is higher. Can I say if the mass is more, pressure will also be more? Mass is directly proportional to pressure. In one area, there are 10 air molecules. In another one area, let's say there are 20 air molecules. This is 20, this is 10. Which is having high pressure, which is having low pressure? This has more mass. More mass means more pressure. So it means this area is high pressure, this area is low pressure. Clear? Comparison in between these two, when we compare, this is what. Now let's come to your body. See, again in technical general, this thing you will go, we are going to study basically, but this is one of the most controversial misconception was people has done with respect to creation of lift. Anyone give me a idea how lift will be created? Let's say this is a wing, this is a bottom section, this is a top section. How the lift is created? Anyone, anyone? Rohan, can you give an answer for that? Like how the lift will be generated?
sir, air will be because of this aerofoil shape. The high pressure will be moving the wings upside.
So you are saying high pressure is on downside, low pressure is on upside, right?
Yes, sir.
So because of the pressure difference, the lift is going to be created,
Created, yes, sir.
right? Just for your fact, even NASA rejected this. Pressure difference is the correct answer. You can go for NASA website also, like you just type in Google, is pressure difference the main reason for lift generation? NASA. You will get one website in that theory they had discussed basically. This is wrong. A lot of people do study and do teach that the pressure difference is a main reason. If I ask you, what is the main reason for lift creation? Of course, pressure difference is answer. But this is not the main reason. This is not the primary reason. Now, what do I mean to say basically? See, pressure, this is your area with lesser air mass, that is low pressure. This is your area with lot of air molecule, it means this is high pressure. Now, one basic thing you just need to remember currently right now, we will study in pressure. From the ground, as your altitude increases, what do you think? Air molecule quantity will decrease or increase?
Decrease, sir.
So we suffer hypoxia. That is when you go for Mount Everest and all, basically, you will carry extra oxygen because there is no oxygen at all, basically. So on the ground, you have lot of air molecule, but as you go into air, air molecules are going to be lesser. So can I say on the ground, you have high pressure naturally. Compared to
You-
upper section, you have high pressure naturally over here. And here, you will be having lower pressure. Now, okay. Now, when we talk about this high pressure, how high pressure is created? One reason I said mass. If the mass is more, weight is more, pressure is more. But how mass creates the pressure as per technical syndrome or as per technical aspect? See, when more air molecules are there, number one, another one, lesser air molecules are there. In which region do you think the interaction between air molecules is high? Where the air molecules collide with each other, aram se. There is a
High pressure.
there is a difference between Mumbai metro, the local metro. and the Bangalore metro basically. Bangalore also it is way higher crowd itself, but in afternoon time it's pretty okay. So you are under high pressure on the evening time particularly. Like whenever the people are coming, basically they are coming in a crowd. They are colliding with each other. You are suffocating basically. But on the afternoon time there are no one basically, so you can aram se go and there is no you are not getting in physical touch with other people basically. So there is no irritation. Now here, when the air molecules are lesser, there is very less chances that air molecules are going to collide with each other. Now, pressure, how it works, if the collision is more, can I say when two objects collide with each other, it will generate the energy, it will generate the kinetic energy, the temperature over there. So when the collision increases, pressure will also increase. So on the area where you are having low pressure, because very less air molecules are there, so they are not colliding with each other, in a very easy way. That is the reason why low pressure is created. But when you take about this area where you are having lot of air molecules are continuously colliding with each other. So they are creating a energy over there. Energy, it will neither be created nor be destroyed, but it is transferred from one way to another way. Here, collision increases the temperature. That is basically creating the higher pressure. So pressure, both of these are correct. Collision will also more the collision, more will be the pressure. More the mass, more will be the pressure basically. Is everything okay till now? Okay. Now, let's come back to this. Why I said this uh, pressure difference, yeah, shit. Pressure difference theory is wrong. It is not primarily correct. See, we are on the ground. Just now I said on the ground you will be having high pressure. On the air, when you reach the air, basically you will be having low pressure. Low pressure is created because there is lesser mass of air present in the atmosphere in the higher altitude. That's why in regulation and in meteorology, you will continuously study about 10,000 feet. If you are going basically, supplementary oxygen has to be carried. And this is also asked in meteorology. This will also ask in regulation. Below 10,000 feet, your aircraft is unpressurized. You can easily fly. You can breathe. Now there is a separation also for in this also for young people and old people. We will discuss in detail. This we will discuss in detail in TechGen airframes also, in regulations also, in the human performance basically. Now, ultimately, what I'm trying to say, on the ground, you already have high pressure. On the air, you have low pressure. Yeah, as you go higher side, pressure is going to be decreased. So, can I say, as you are coming downside, pressure is increasing? The reverse of that. So, when you go deep down into the ocean, in the ocean, pressure is very high, very high. The more you go deep down, the more pressure is going to be created. Now, how pressure is going to affect your body? See, you will never feel pressure. I mean, if some mass is kept on your body, you will feel pressure. Yeah, बहुत भारी है. But if you are a normal person who is just sitting as it is, you are sitting in the class, you will not feel pressure. Why? Your body, your body मेरे को नहीं पता कैसे बनाते हैं. Imagine your body is this. Now, inside your body, there is a fact. This is 99% you are having the liquid, that is the water, basically. Again, in human performance, you will study basically whenever you eat any food, basically as a byproduct, you will release the this water, basically. This is also one thing I seen people feel human performance is very boring, but regulations में मेरे को कुछ अच्छा लगता है तो human performance है. मतलब that is quite good if you, because it is conceptual. There is nothing to bad basically. Now, what happens in your body? You have a liquid. This liquid is continuously exerting the pressure outside. On the atmosphere, you have high pressure, as I discussed earlier. So, on the surrounding of you, you can't see the air. If you can see, then you could have find it basically because you can't see the air. Air is continuously exerting the pressure inside your body. Now, you will not feel any sort of pressure on the normal ground because the pressure which is created by body inside will be equal to pressure outside. So your body is equalizing the pressure which is there in the atmosphere. Actually, we are being squeezed by the pressure. High pressure means high squeezed. You are going to be a Golgappa basically. A lot of squeezing will happen. Now this will only work in the ground. Now, इसको मान के if you get into the scuba dive, those all jackets and you go deep down into the ocean, 300 feet, 400 feet, 500 feet deep down, when you go down, pressure will increase. That is, high pressure is going to be created. More down you are going, more high pressure. So let's say this is 100 units earlier on the ground. This is also 100 units. It is equalized. But as you go deep down into the ocean, the outside pressure will increase to 150. So that extra 50 hectopascal of pressure, it will start squeezing your body basically. And this I advise for the people also. If you, I mean, instead of watching reels, you can watch that movie basically. At least patriotism to badega thoda bahut. That is basically Ghazi attack. This is basically the Pakistan and India warfare basically. Now उसमें क्या होता है कि वो जो vessel है, the the what is that यार, underwater vessel we call it as
Submarine.
submarine, yeah. So the submarine, it's, I think the radar got failed basically, so they cannot move left or right side. They will only move up or down basically. Now when they go deep down basically, this is a submarine, imagine. So from as you go deep down, the pressure is continuously increasing and continuously it is exerting on the body. That metal frame can easily break. It will not even tolerate the pressure or that much of pressure on the deep ocean. Now, if you go deep down into the ocean, you will be squeezed a lot. Your head is going to be busted out, basically. So, this is a reason in the ground we will not feel it. And this is a reason why DGCA also gives some time limitation. In regulation, we'll studies after scuba diving, you cannot directly get into the flight. You have to rest for some period being basically. This is the reason, because pressure difference was, I mean, there is a difference of pressure. Your body is not adjusted to the normal ground pressure. That's why you need to take a rest. Now pressure concept is understood for you guys, how the pressure is there. Now why this theory is wrong? Yeah, what did you said, how the lift is created? It is created because of the creation of pressure difference, right? Am I right, Rohan?
Yes, sir.
Yeah. Now you say me, how do you create the high pressure? ग्राउंड पे ऑलरेडी हाई प्रेशर है. ग्राउंड पे ऑलरेडी हाई प्रेशर है तो आप तो हाई प्रेशर क्रिएट ही नहीं कर रहे हो. वो तो ऑलरेडी है यहाँ पे. व्हाट वी नीड टू क्रिएट इज मेनली लो प्रेशर. हाउ डू यू क्रिएट द लो प्रेशर? यार, more air molecule means more high pressure basically. Now in
Sir,
the
by
ground,
distributing the air molecules.
no, 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 no. Now in the ground, see, if you want to create the low pressure, the air molecule has to be decreased basically, right? Am I correct in this? Now, your aircraft aerofoil, I mean, your aircraft wing is made up of aerofoil shape. Again, I'll not go in complete detail what is this aerofoil shape. Already in the ground, you have high pressure. There is nothing to create as high pressure. When you increase the velocity, what happens to air? What happens to pressure? You are standing on a place, you are feeling lot of air molecules from the surrounding. But the moment when you start moving, basically, the air molecule which are earlier when your aircraft is on parking bay, these all air molecules are placed on your aircraft. Your aircraft was not creating the lift on the parking bay because the amount of air molecule what you're having on the bottom, high pressure, which is equal to high pressure on the top side also. But
Sir,
whenever
it was while it was stationary, it was facing the what to say, static pressure.
no, static pressure basically. I mean, it's better I'll not go for static and dynamic pressure, to avoid the confusion. That's why I'm giving a very simple words. Navigation, if you had studied, then you can relate. But if I took dynamic and static pressure by chance over here, I'm going to be messed up. So that's why I'll take a easy words. On the downside, you will be having some amount of air molecule, let's say 100. On the top also you have 100 air molecules only because there is no pressure difference. आपका aircraft lift नहीं create कर रहा है. Now, again, I'm saying reason for lift is not creation of pressure difference. The wording is wrong. Creation of pressure difference is wrong. What you are doing, आपको अगर lift create करना है ना, तो you have to create high pressure on one side, low pressure on another one side. But naturally inbuilt in the atmosphere, you have high pressure. So you don't need to create the high pressure again. What you have to create is low pressure. And आपको ऊपर जाना है. If you want to go upside, you need to create the low pressure on the top side basically. How do you create the low pressure? When the aircraft is on ground, you are not moving. Velocity is zero. The moment your aircraft starts moving, this all air molecule will get washed out. So they are not sitting on the wings of our aircraft. So this air molecule, which was earlier 100, now probably it may be 30 or 20 air molecule which is remaining. So lesser air molecule means lesser mass. Lesser mass means low pressure. So this is how pressure difference was created. So if I say the lift creation main reason, option A, creation of low pressure. Option B, pressure difference. Now what is your answer?
Alpha.
क्रिएशन ऑफ लो प्रेशर. आप हाई प्रेशर क्रिएट ही नहीं कर रहे हो. हाई प्रेशर ऑलरेडी है एटमॉस्फेयर पे. योर रोल इज टू क्रिएट द लो प्रेशर. मोर द लो प्रेशर यू आर क्रिएटिंग, मोर प्रेशर डिफरेंस, मोर लिफ्ट. अल्टीमेटली व्हेन यू क्रिएट द लो प्रेशर, प्रेशर डिफरेंस इज गोइंग टू क्रिएट द लिफ्ट. बट दिस इज नॉट द प्राइमरी थिंग. पहले आपको लो प्रेशर क्रिएट करना है, उसके बाद प्रेशर डिफरेंस. बट इन एग्जाम there is a lesser chances they will give this option. Whenever this option is not there, you can go with this pressure difference. That's why people will always go with this. Basically, a lot of people do not know this thing. This one, I think, in Oxford also, basically that word is mentioned. I think I somewhere have that. Yeah, here. So that pressure difference theory, what you said, that is high pressure and low pressure creation, that theory is basically called as longer path or equal transit theory. I'll not go with that basically. I mean, it is more or less same itself, high pressure and low pressure creation. But the NASA has clearly denied this. Where unfortunately, many of this theory, which is in the website or encyclopedia, is incorrect. So that pressure difference theory was rejected even by NASA. And you can see in your Oxford also. Oxford, they had given correcting. Yeah, Oxford is a very good book if you want to study for navigation also, if you want to study for tech gen also. But उसमें problem ये है कि आपको कुछ आइडिया होना चाहिए. इफ यू डोंट नो एनीथिंग एंड इफ फ्रॉम स्क्रैच इफ यू आर गोइंग, यू आर बेसिकली कुक्ड बाय ऑक्सफोर्ड. एक पैरा अगर समझ आया ना, तो दैट इज यू आर डूइंग वेरी ग्रेट थिंग इन दैट. इट्स वेरी कॉम्प्लेक्स इन टर्म्स ऑफ, इट इज वेरी गुड. बट so you see this line, what they had given. Lift is, this is taken from Oxford. This screenshot I taken from Oxford. Lift is created by the pressure difference between the top and the bottom surface, what you had said. That is high pressure and the low pressure difference. वो बंदा यहाँ पे चुप हो सकता था. वो थोड़ी ना पागल है. सेकंड लाइन भी लिखा है वहां पे. What he has written, pressure is reduced by the air accelerating over the top. Basically, he is saying how low pressure is created. If he has said low pressure is created, why didn't he said high pressure is also how high pressure will be created? High pressure is already there in the atmosphere. So आपको create करना नहीं है. So main reason for lift is
I mean,
creation.
so theoretically, it's a pressure difference, but if you
Yeah.
will look on the
Pressure
conceptual, then
difference
it's
will
like
only come, pressure difference will
air
only
washing
come
or
when you
the
create a low pressure.
high pressure from the above.
Yeah, yeah. So pressure difference is a reason, but pressure difference only comes when you create a low pressure in the atmosphere. And उसको कैसे create करोगे? By increasing the velocity so that the air molecule on the top will wash out. Clear? I mean, this is quite off the track basically, but if you people are studying tech gen on your own or thinking like that, please do not make this mistake. That's why I just give this topic. But again, in the exam, if they ask high, if they give both the option, pressure difference creation or low pressure creation, then the answer is low pressure creation. But most of the time, they will not give that option. They will give this pressure difference itself. For exam purpose, remember as it is, whatever running in the market. But true exam answer is this one. So in the interview, in the airline interview, if they ask, they are not expecting this one. They're expecting this one. That is creation of low pressure. Clear? Okay. Now I hope you guys are very much familiar with the pressure. Shall we move for next topic in our methodology? Anyone need, what is the time? Okay, 25. We can continue, right? The reason why I kept met after regulation is, see, till now we had discussed around some 30-40 minutes. Is very interesting. I mean, we never get to know how time is going. But in regulation, I always keep watching time basically. What is the time? What is the time? I mean, it's very much factual. वो बहुत boring होता है मतलब. Okay, now come to this. temperature. So what I'm saying in this is basically you have a pole. Pole is lesser temperature. Lesser temperature means no air is moving upper side. If no air is moving upper side, it means all the air is confined to the lower level itself. Lower level itself means huge amount of air molecule are there, which is creating high pressure. Now on this side, on the equator, you have a lot of temperature. So it means it is it is pushing the air molecule upside basically. When they push the air molecule upside, there is no air molecule on the ground or less air molecule on the ground, it will create a low pressure. Clear? Now this is on ground. Let's say this is 10 kilometer. Imagine करने Now all the air molecule which was earlier on the low pressure on the downside, now they had gone for top areas. So in the top area you are having, let's say, more air molecule. So what it is creating? It is creating high pressure on the equator. Will not take 10 kilometer because reversal will happen after 8. That reversal I'll say in next classes. Let's say 5 kilometer. So on the 5 kilometer, because of the temperature increase, all the air molecule goes top, it creates high pressure. Now यहाँ पे there is no energy itself to go up. There is no air molecule on the top section of the polar region, so it will create the low pressure over here. Now, convection means vertical, movement upward or downward, upward mainly. Advection means horizontal. Now, always remember, I'll give a justification also why it is so over here. When you talk about advection, which is horizontal movement, it will always happen from high pressure to low pressure. Why? High pressure means more air molecule. Low pressure means less air molecule or no air molecule. यार एक वेजल में पूरा पानी भरा हुआ है, एक वेजल खाली है. अगर आप वहां पे एक कम्युनिकेशन देते हो, एक ट्रांसपोर्टेशन का मैकेनिज्म देते हो, बिकॉज इट इज heavy with the water, it is high pressure, more air mass. There is no water in this. This is low pressure. या जहाँ पे ज्यादा है वहां से खाली जगह जाता है ना, एनवायरमेंट में भी नेचुरल है बेसिकली. when your dams are going to be overloaded, they are going to flooding into the atmosphere basically. So the same thing happens in our natural atmosphere also. The air molecules are more in the high pressure. There is no air molecule in the low pressure, so naturally they will move like this. This is the reason why advection happens horizontally. And advection, please do remember, it is a basic of our meteorology. Without this, there is nothing. Always wind movement is from high to low, high pressure to low pressure. Is it clear? Next. Next one is convection. You just remember advection. The opposite of advection is convection. Convection will happen vertically, but in this, from low pressure, air molecule will move to high pressure. Advection horizontal, high to low. Convection vertical, low to high. I'll say the reason also for that. Now come back to this point. Equator, high temperature, that's why air molecule goes up. Low pressure on the bottom, high pressure on the top. Polar, there is no temperature, so all the air molecule confined to the ground, high pressure on the ground and low pressure on the top side. If it is not pole, for our convenience, let's say this is temperate region. Temperate region compared to our tropics, it's again pretty much colder itself basically. Now you see the magic in this. How advection happens? Horizontal or vertical? Advection happens horizontal or vertical? Anyone? Siddharth?
Horizontal.
Horizontal. So there is high pressure on the temperate region. From here, air molecule horizontally will move to the low pressure region. Now, from this high pressure region, when the air molecule move into this area, it means it is adding up some of the air molecule. It is taking up some of the air molecule. Now, this is basically advection. Convection is vertical, vertically from high to low or low to high. Convection,
Low
Low
to
to
high.
high.
low to high. So this is low, this is high. Air molecules are moving top. This is convection. Now again you see on this side, this is high, this is low. horizontal movement of air. This is advection. This is low, this is high. Again, this is convection. Now, if you observe in this, can we say there is a loop which is created? Air is going from high pressure to low pressure. From here again it is वो ऊपर जा रहा है. ऊपर जाके वहां पे हाई प्रेशर होता है तो हाई प्रेशर से लो प्रेशर अगेन हॉरिजॉन्टली मूव हो रहा है. एंड फ्रॉम लो प्रेशर अगेन इट इज कमिंग डाउन. So winds are never confined to one particular region. Winds are always circulatory. They keep on moving from one place to another place. मेरे को एक क्वेश्चन पूछा था एक बंदे ने. आई मीन इट वाज वेरी गुड क्वेश्चन बेसिकली. इन पोल्स देर आर वेरी लेस पीपल हु आर लिविंग. इट मीन्स वहाँ पे ज़्यादा लोग नहीं है. टेम्परेट रीजन पे देर आर पीपल. टेम्परेट रीजन मीन्स योर मेन रशिया पार्ट एंड योर यूरोप पार्ट एंड योर नॉर्थ अमेरिका एंड ऑल दिस रीजन वॉट यू आर सीइंग दैट पार्ट. उसने मेरे को एक क्वेश्चन पूछा. देर इज अ कॉन्सेप्ट ऑफ ओजोन बेसिकली इन चैप्टर 1 वी आर गोइंग टू स्टडी इट. नाउ ओजोन व्हाट इट विल डू. दिस इज आवर लैंड. दिस इज अ ओजोन. There are three forms of radiation which come from the sun. In that, one of the radiation is very much injurious for our body, that is UV radiation. Now, this ozone layer will re-radiate that UV radiation back to sun. It will not allow the radiation to come into our earth. But what happens because of the pollution, uh, this ozone layer which was over here, shit, yeah, how to erase this here? Single. Okay, I mean, I'll draw separately. Because of the pollution, ozone layer got depleted. Now, how it is going to be depleted in chapter 1, I'll give you that reaction. It is not required, but still, I'll give that reaction. Now, in between, if you see, these areas are empty. There is no ozone. One thing in this UV radiation will come into the earth, which is bad for us, which can create skin cancer. Now, areas where there is no ozone, this region is called as ozone hole. One of the main reason why ozone is going to deplete, that means the ozone hole is going to be created, is because of CFC. The CFC is a chemical, the chlorofluorocarbons. For example, in your refrigerants, in your fridges and all, we are going to use it, and in the industries, they are going to release it basically. You guys also answer. We'll see like who will answer it. Yeah, imagine you are living in the temperate region. You are creating the pollution here. But ozone before COVID, yeah, in COVID, if one thing which happened good is basically the ozone layer which was earlier depleted, it recovered basically because we produce less pollution. लॉकडाउन हुआ तो सभी लोग घर पे ही थे तो व्हीकल पोल्यूशन थोड़ा कम हुआ तो ओजोन स्टार्ट्स रिकैपिंग इटसेल्फ बेसिकली. दैट इज ओनली वन गुड थिंग इन कोविड which happened. Now, earlier, before COVID, basically, when the ozone depletion is happening, people who are living in the temperate region, they are creating the pollution. बट ओजोन डिप्लीशन जो है वो पोल्स में भी हो रहा था. व्हाई इज दिस रीजन. व्हाई इज दिस रीजन. जहां पे पोल्यूशन है वहां पे होना है ना. पोल्स पे क्यों हो रहा है. पोल्स पे तो कोई भी नहीं.
Convection.
Convection fine. I mean, both convection and advection is the answer in that sense. The answer is circulation of air.
So from high to low.
सर्कुलेशन ऑफ एयर. अभी मैंने बोला यहाँ पे एक रीजन से दूसरी रीजन विंड जाता है. सो फॉर एग्जांपल इफ यू कंसिडर टेम्परेट इज दिस वन. This is your let's say poles. Air on the higher altitude from temperate region it is moving towards the polar region, and that too on the higher altitude itself. So all the pollution what you are having on the temperate region, you are spreading it to the poles also because of the advection basically. So this is a reason why in ozone, sorry, why in poles we will see the pollution also. किसी को कोई डाउट यहाँ तक. सूरज, you came just now.
Yes, sir.
Okay, okay, fine. Any doubt still here for anyone? Shall we move on? Shall we continue? We will we will do another 45 minutes. I hope you have a capacity of that, or we'll stop before that. Whenever you guys are exhausted, please do inform me. I'll not go in a hurry. We'll go around. Say by 13 we will complete. Don't worry. Now, There is a concept called as general circulation in chapter number 20, basically. Now, two things you need to remember for this, which I already mentioned. Advection is high pressure to low pressure, which is horizontal. Convection is low to high pressure, which is vertical. Is it fine? Anyone having any issues in this? No, right? Shall we continue? Yeah. Now, again, you take a Earth, you have a equator, you have a tropics, you have a temperate, you have a pole. You take a pole this side, temperate, and the tropics. Now, instead of writing as circle like this, basically, can I cut this? Can I cut this circle and make it straight like this? Is there any issue in that? This portion I'm cutting basically, this curved what is there, imagine that I'm making it straight. We can do that, right? So in that, in the center, what it's going to create is equator. This side you are having northern hemisphere, that is this part. This side you are having southern hemisphere, that is this part. Is it clear till now? Anyone, any issue? All right. Now, hmm. So this is your equator. This is 30-degree north. This is 60-degree north. 1 minute. This is 60-degree north. And this one is your 90-degree north. Same like that, this side. This is your 30-degree north. This is your 60-degree north. And this is your 90-degree north. Equator is having high temperature or low temperature. Equator has lot of temperature. High temperature means, yeah, earlier there were a lot of air molecule, but now because of the temperature, all the air molecule move upper side. So now in the high temperature region, as this air molecule starts moving upper side, there is only few air molecule which remained on the ground. So can I say wherever high temperature is there low pressure will be created. This rule, that is temperature is inversely proportional to pressure. Simply I can say this will only apply in the metrology. Your Charles law, Boyle's law, these all what laws you are going to see in the text. And in everything, if you see, keeping temperature constant, keeping pressure constant, keeping volume constant. So everything, something we keep as constant basically. There is nothing like perfect. So in the metrology, for our assumption, we will consider if the temperature is more high temperature, means pressure will be lower, lesser pressure basically. And the reason also I said all the air molecule move upper side. There is no weight on the air on the lower side. It will create a low pressure. So basically, I can say, yeah, this is a ground. Okay, this is a ground. This is, let's say, 5 kilometer on the air. Now I need your imagination. This basically. On the equator, just now I showed this is going to be low pressure. Earlier, air molecules are on the ground, which is high pressure, but now because of intense temperature, low pressure is created here. Means exactly on the top, exactly on the higher altitude, can I say high pressure is created on the equator? On the ground, it is low pressure. On the top, exactly on the top, it is high pressure. Am I right? Now, this is the only thing you need to remember. यहाँ से बस zigzag खेलना है बस. See, always remember one thing. If one region is low pressure, another one region will be for sure high pressure. You don't need to go back to the reason for this. If one region is high pressure, another one region is always low pressure. Because air molecules will not be constant in all the region. In one region you have 100 air molecule. In another one region you have 98 air molecule. So 100 is high pressure. Comparably 98 is low pressure. So air molecules wherever it is uniform, it will be equal pressure. But air molecule uniform नहीं होता है सभी जगह. So the pressure difference will be there. High pressure will be there. Low pressure will be there. Now on the ground, in the equator you have low, high. This low pressure means 30-degree. It will be high pressure. If this is high pressure, this will be low pressure. If this is low pressure, this will be high pressure. Same, you take it for this side. If this is low pressure, this will be high pressure. This will be low pressure. This will be high pressure. Now you see this side, this is also very logical. This 90-degree high pressure, what you are having, this is also very logical. What did I said? In the poles, according to this, on the ground we have high pressure. Now I will justify this how it is. On the poles, you are having temperature lesser. Lesser temperature means all the air molecule confined to the ground only. So if all the air molecule confined to ground means it is high pressure. So like that we can justify for everything, but no need basically. You just remember this zigzag, that is more than enough. Now, again that zigzag continues over here also. If this is high pressure, exactly on the air in 30-degree it will be low pressure. Now you compare this to also. On the ground it is high pressure, on the top it will definitely be low pressure. So from everywhere it is balanced. Now this is basically, if this is low pressure, this will be high pressure. If this is high pressure, this will be low pressure. So high pressure on the ground, low pressure on the air, again balanced. Same this side, this is low pressure, this is high pressure, this is low pressure. Now give me that advection and convection. Advection is horizontal or vertical?
Horizontal.
Horizontal.
Horizontally, sir.
Advection will be from low pressure to high pressure or high pressure to low pressure?
High to low.
High to low. Now take this 30-degree north. 30-degree north is high. Can I say wind will move like this horizontally? Next, convection, we know vertical movement from low to high, low pressure to high pressure. Next, high to low, low to high. Can I say this created one loop that air molecule, this is also a reason between the regions, between the tropic, between the temperate, between the poles, air is not mixing. It is very rarely they are going to be mixed up basically, because this loop is created. See, on the we are living on, if you are living on Delhi, something 28-degree north, you are going to live basically near to 30-degree basically. So from 30-degree north, wind will horizontally blow to equator. On the equator, they will rise into 5 kilometer. From the equator, 5 kilometer top, they will again come to your tropics, your Delhi higher region. From Delhi higher region, the wind will blow back to your region. So the wave which started from this point, after making one circle, it again comes back to our same point. So this is a loop which is created, and this loop is called as Hadley cell. Cell means basically the revolution. So because it is rotating on the this region itself, it is called as Hadley cell. So Hadley cell, in the exam, if they ask you, it is basically 0 to 30-degree north or south. Because on this side also, if you see the same thing happen, high to low, low to high, high to low, low to high. So again, the wind is trapped on this side also on the southern, I mean, tropics itself, tropics and 0 degree. Now, further moving, high pressure to low pressure, horizontal, low to high, this convection, high to low, advection, low to high, convection. This second loop which is created over here, this loop is called as Ferrel cell. Logical, everything, there is nothing to back. So second one, Ferrel cell is 30 to 60-degree north or south. I mean, this side also the same thing. I will not draw that side, the same replica you can imagine. Next, high to low, low to high, high to low, low to high. This one loop which created is called as polar cell. Polar cell is easier. Polar cell, on the poles it is creating, that's why we call it as polar cell, which is 60 to 90-degree north or south. I'll just take some remaining 15-20 minutes. I need to explain one concept, because if I didn't explain it today, this concept I need to explain tomorrow also. So that's why I'll finish that concept. After that, we'll wrap up the class basically. Now, any doubts in this? The tropics is the circular loop is created is Hadley, the temperate is Ferrel, and the polar side is basically your polar cell. Now, the same thing, I'm doing nothing changes in this. I'm drawing on the actual Earth. So this is your equator. On the equator, on the ground, you are having low pressure, right? Because of the higher temperature. This is your ground. I need your imagination for this. This is your ground. On these regions, this is your higher altitude, the upper wala, the air molecule. So if you write this, this is your 30 degree, this is your 60 degree, this is your 90 degree. 90 degree, you will be having high pressure on the ground. If this is low pressure, this is high pressure. This is low pressure, high pressure. On the air, on the exact top side, basically, this is high pressure, low pressure, high pressure. This is high pressure, no? So this is low pressure. So now again that circle will follow. Advection, horizontal, convection, vertical, advection, horizontal. Here, this is high pressure. Hmm. So this is what I said is your Hadley cell, right? Now, high to low, low to high, high to low, low to high. This is your ferrule, high to low, low to high, high to low, low to high. This is your polar. I had changed nothing. The straight line, I just made it on atmosphere. Any doubt still here? Clear? Now, what did I said? What is the what is the wind movement basically? When I say wind movement, until and unless I'm not saying convection, it is always advection. Horizontal movement of air is called as wind. This is a definition. Convection is not called as wind. Horizontal movement is called as wind. So whenever I say wind, wind is moving from high to low. That is understandable, which is horizontal. Now, here just for 5 minutes you concentrate. This is a low pressure region. This is a high pressure region. This is a low pressure region. This is a pole where high pressure I had already written. It may look vertical for you, but imagine this is a horizontal itself. From one region, you are going to another region. From the equator, you are going to pole. From the Africa, let's say you are going to Delhi, basically. Wind movement happens high to low, basically. So here, can I write wind movement like this? Any issues in this? Wind movement, this looks vertical, but please do imagine it as horizontal. So horizontal wind is always from high to low. So this is drawn like this. And this side, can I say this is high, this is low? That's why high to low means this movement of the wind. Now, this is high, this is low, this movement of the wind. Now, the same thing you can write on this side also. 30 degree, 60 degree. If this is low pressure, this is high pressure, this is low pressure. Polar will be low, high pressure. So wind movement, I'll take some different color. High to low will be like this. High to low on this side will be like this. High to low will be like this. Any doubts in this? Clear? If Earth is not rotating, not only the rotational force, there are a lot of things which compiles basically for the bending of the wind. Because one of the main reason is Earth is rotating basically, the wind in our Earth will never go straight. It will either bend towards left side, right side, sorry, correction, or it will either bend towards left side. So the winds, this you just short. This you just remember right now as it is. I mean, I'll not explain Coriolis force. The wind which are moving straight, there is nothing straight in the earth. It is always bending. Now, this curved wind which is moving, this is called as Coriolis force. Coriolis force is zero on equator. It is high or it is maximum on pole. Explanation I'll give in chapter number 6, wind. It is not a portion of this one. बस आपको ये याद रखना है कि कोरियोलिस फोर्स मींस नथिंग बट इट इज बेंडिंग ऑफ द विंड विंड्स विच जो स्ट्राइट जाता था उसको बेंड किया है नाउ मेन थिंग व्हाट यू नीड टू रिमेंबर कोरियोलिस फोर्स on northern hemisphere bend towards right side. If the wind is moving like this, wind will turn like this. This is very, very, very important for exam. Coriolis force On the southern hemisphere, bend towards left side or the port side. So if the wind is moving like this, it will move like this. Is it clear? Now what I'm going to say, that is important. You need to focus. Earlier we imagined that wind is moving straight, but now we got to know that Coriolis force is a bending force which is actually present in the atmosphere. Below this, this is southern hemisphere. Above this, this is northern hemisphere. So wind which was moving straight in the southern hemisphere, it will tilt towards left side. It means wind was not actually straight like this. It was actually bending. So in the black color, what I'm writing, that is the actual wind, what you see in the atmosphere. It is moving like this. Now here, yeah, this is high pressure, this is low pressure. Ulta hai. Ulta you are going basically. I mean, this may looks right for you, but this is a left because you are going on the reverse order basically. Ulta ja rahe ho aap. So your left is my right is your left because we are opposite to each other. Same like that. यहाँ पे high pressure से low pressure you are going straight, you will consider this side itself as a left. But when you are going high to low, which is on downside, you are going on a reverse order basically, if you imagine that. So this looks like right, but this is actually your left side. So wind is blowing like this. Now this is high to low, you are going on a straight way itself. The wind will bend towards this side. Now on the top side also, again, high to low you are coming, it means you are coming on the ulta. This, see, northern hemisphere, wind will bend towards the right side. So first I will do for this one, high to low. You are going straight. Northern hemisphere right side bend means bend will happen to the right side. On the direction of the movement itself, it is going. Now in this region, high to low, you are going on the ulta direction basically. You are coming from this point to this point. It may look left for you, but it is actually right. Okay. Next, this one also, it may look right for you, but this is actually right. Is it clear till now? Now, if you observe over here, from this side also, this is a equator line. From this side also wind is coming, and from this side also wind is coming. So equator is there. From northern hemisphere also wind is coming. From southern hemisphere also wind is coming. So can I say they are converging? They are colliding with each other. This zone, wherever they are converging, this is called as ITCZ, Intertropical Convergence Zone. Intertropical because both of them are in tropics itself. 0 to 30 degree north, 0 to 30 degree south. So आपका college अगर sports करता है तो inter college or inter university, what we do same like that, intertropical, because they are converging. That is why we call it as convergence zone, intertropical convergence zone. Intertropical convergence zone जहां पे भी होता है, wherever the intertropical convergence zone is there, abundance amount of rainfall is going to happen because clouds are literally colliding with each other. When they collide, basically they are mixing up, they will saturate, they will create rainfall. So in this equator band, that's the reason now you will understand why Amazon forest is evergreen. Why your, I think one of the guys from Tripura, why your Northeast is evergreen. Why your Singapore region or, this Philippine region is full of the forest basically. These all region, wherever this ITCZ is moving, those all region are basically evergreen. ऊपर थोड़ा in Africa also basically people do, sorry यार. I think something like this the Africa will look, where people go for South Africa for flying. This is where. Over here, Sahara Desert is there. Because that is on the top of this IT season. There is no rainfall happening over there. But if you come to this regions, that is basically, I'm quite weak in geography. I don't know what is this. There are some regions, there are some countries over here. I exactly don't know the name of that. But just see below this Sahara Desert, the places which are present over here, these are greenery. So in Africa also there is, not everywhere it's a dryness. There are also a lot of greeneries in Africa, only in the zone where this ITCZ is moving on. So ITCZ is directly proportional to rainfall. And ITCZ is not fixed. It will move as the sun move up and down. That is we call as SSP. We will discuss this tomorrow. Today we will not go for that. Sun, I hope you all know. If it is summer for us, sun is on northern hemisphere. If it is winter for us, it means sun is on the literally on the southern hemisphere. So sun ऊपर नीचे जाता है. However, I mean, how the sun is moving up, ITCZ will also move up. If the sun is moving down, ITCZ will also move down. So this ITCZ is not fixed to equator 0 degree. It will move 5 degree north to 5 degree south. आप कोई भी
Sir, so that every cell will also move 5 degree north and south.
हाँ, every cell will move basically. So that I mean, you can say right now also if you are not confusing basically, but it's better you can talk about that later. But every cell will move. Every cell, as the sun movement is going up and down, basically they will expand and contrast basically. But if some people is not understanding this word which I just now said, please don't worry. In the classes again when we see, we will look into that. So this area, wherever ITCZ is forming between 5 degree north and 5 degree south, you search in the Google those areas, those all areas are greeneries. There are a lot of forest. In this region only your, this South American region, that is your, what is your Brazil and all, what you are seeing, the Amazon forest and all, it will come in this region. Your African region is also greenery. Some of the Indian region will come on this belt, and your mainly your Southeast nations. That is your Singapore, Thailand, Malaysia, all this. If you just know, Myanmar will also come near to this. Myanmar is a spot of terrorist hub. Terrorists will use that area because to hide themselves because there is a dense forest. In that dense forest, it is very difficult to find those people basically. So this area ITCZ will give rainfall, which will make them evergreen. Lot of dense forest is there. Okay. Now, last one thing, after that we'll stop this class today. So what is happening? Wind can either move from west to east direction, or wind will either move from east to west direction. It can move north to south also, south to north also. It is not required here. We will just go with this. See, wherever winds are originating, we will give the name of that wind with respect to that direction. For example, if the wind is starting from west, it is moving to east. The origination point is west. So that's why this one we call it as westerly. But if the wind started from east, they are moving towards west, this is called as easterly. So lee is common. This is basically wherever the wind is originated. If it is started from east to west, easterly. If it is started from west to east, that is westerly. Now you see here, can I say this is moving east to west? This side is east, this side is west. It is quietly moving east to west. So can I say both of these winds are moving from east direction towards the west direction? So this 0 to 30 degree, 0 to 30 degree, and your ITCs are also. They are easterly in direction. Any doubts for anyone in this? No. Next. You see this wind. This wind is moving like this. It means in the ground, it is moving like this. What is this? West to east. So it is not exactly moving straight, but it is moving towards the east basically. The same like that on the downside also, if you see, it is moving towards east. It is something like this. It is moving towards east.
But originating from west.
Originating from west. So 30 to 60 degree, it is basically westerly wind. And again from 60 to 90, basically, this is from east to west. If you see, this is something like this. And on the downside also, it is moving like this. So it is again easterly. 60 to 90 is easterly. So this is what today you guys need to study about. Any doubts in whatever we do?
No, sir. Sir,
So
is that, I mean, you will provide the note now, so it is mentioned in the note, right?
these all things basically in one or the other, another chapter we have mentioned all these
Okay.
details basically. This diagram, if you want, you can take a screenshot. This is not mentioned basically. But other things, although it is not given as a PPT or whatever, see, everything what is in my mind, whichever I can connect basically, that I will use on spot. The same way of teaching will not be gone for our next batch basically. So uh, the chapters when they actually start, everything is included in that, except this one diagram. If you want to take a screenshot, you can take it basically. These topics, whatever we have discussed right now, this will discuss again and again in the future also. But these diagrams I will not explain over there.
Sir,
So
now I can mostly relate the questions of this flying things. The questions this time, this question comes like if you are flying from this Delhi to Chennai, which wind you can
that you
foresee?
will see in the pressure
So,
chapter. People will buy at the drifts, port drift or starboard drift, what you are saying, people will buy at that.
yeah,
But
sir, now actually I'm getting the conceptual things.
so if you know high to low movement, basically there is another one law which we call as boy something Bayes buoyant law, I guess basically. I don't want to pronounce.
Vice Balotla, sir.
Price ballot law basically. It will say if your wind is on the back side, your left side will be low pressure, your right side will be high pressure. These two concepts you will apply and you will get your drift. It is very easy question, but people will buy at that if they do not know the concept. So today, you guys digest this thing. We have discussed a lot of things basically. We'll stop it right here today. I can see the face of
Sure,
Pratik
sir,
so
sure.
basically.
It's been a little bit
Yeah,
even
so
fuzzy
if
for
I
me.
discuss anything more than this, then it's all waste basically. I thought of completing this, but it's okay. Tomorrow we'll do mountains. What is the role of mountain? Pressure we discussed, temperature we discussed, general circulations we discussed. These three things I'll discuss tomorrow with the winds. So that's why I said starting two classes, I'll do basic thing. After that only we will jump into the classes. When we jump into classes by knowing these concepts, it will be very easy for you guys. So any doubts, anyone?
No, sir, it's fine.
1 minute. Yeah. With respect to class timings here, I just inform in the WhatsApp. This timing is okay for everyone, right? Except Pratik. Pratik, can you manage these timings?
I mean, it's only Friday.